All right, here's some homework help for the permutation section. First two questions are just calculator questions. So 3 pick 3, or 3 permutations of 3, and 0 factorial. Let's just do that here. So I want to get permutations. So under functions and stats, there's permutations. Make sure you're picking perm, not combinations. And then 3, comma, 3. And so 3 permutations of 3 are 6. Good. And then they want to know what 0 factorial is. So 0, and then under ABC, there's our factorial button. It's equal to 1. So that's equal to 1. Oh, those are nice ones. Next question. How many permutations are there in the letters of the following word if all the letters are used and no repeating? So if there's no repeating, then we can use permutations. So how many letters are there? 4. There's 7 letters. So I can say there's 7 letters, and I want to arrange them in permutations of 7. So that's one way I could answer that. Now another way I could answer it is I could just say, well, there's 7 letters. Okay, there's 7. How many could I put in this first spot? 7. How many could I put in the second spot? If I've already used one, I could do 6, etc., all the way down to the bottom. So that would be, those two things would be the same thing. And another way of writing that 7 times 6 times 5 is 7 factorial. So it would be that answer, and I think this answer. I think that's all of them right there. Okay, program is planned to have 6 musical numbers, 6 speeches. In how many ways can this be done if a musical number and a speech are to alternate and a musical number is to come first? Okay, so I've got to have music, speech. That's a long meeting. Not wanting to go to this one. Music, speech, etc. So how many musical numbers are there? 6. Times, how many speeches are there? 6. Musical number, I can't use the first one, so there'd only be 5 left. Can't use the first speech, so there'd only be 5 speeches left, etc. You see the pattern? And basically you have 6 factorial for the music times 6 factorial for the speeches. So whatever 6 factorial times 6 factorial is. Let's pull out the calculator. So I want to go 6 factorial times 6 factorial. 518,400. 518,400. That's how many different ways you could do that. I'm not going to that. Okay, codes. How many code symbols can be formed using 4 of the 6 letters? So I've got 4 spots. 1, 2, 3, 4. And I have to use some of these letters. Okay, first, if they're not repeated. So I could put 6 in the first one. 6 different letters. And in the next one, if I can't repeat, then I only have 5 for the next one. And then I'd have 4 for the next one and 3 for the next one. So what's that? 30 times 12 would be 360. Now another way, so 360. Oh, they want me to say what way I could write that. Well, there's 6 letters, and I'm wanting to find permutations of 4. So 6 pick 4, that one. I think that would be, I don't think there's any other ways I could write that. Nope, I think it's just that one. Okay, now if you can repeat them. So if you can repeat things, I've got my calculator in there. I'll use that later. If I can repeat things, then again I have 4 slots. I have 6 letters, so I can put 6 in the first one, but then I could also put 6 in the second, third, and fourth spots. So 6 times 6 times 6 times 6, or 6 to the 4th, that'd be how many ways I could do it if I could repeat. All right, the next question says, not repeated, but must begin with a D. Okay, not repeated, but they must begin with a D. So, in the first slot, it has to be a D. So there's only really one way to do that. And then I've got 3 other slots. So if I've used up the D, then there would be 5 letters left times 4 times 3. So 5 times 4 is 20 times 3, so there'd be 60 ways. Proper notation for that. I guess there's 5 things, and you're wanting to choose 3 of them. Not choose, pick, because the order's important. 5 things, and I'm picking 3 of them. And that'd be my answer. And if I wanted to write 1 times in front of that, you could do that too. There, so letter B, that's what I'd be saying. Okay, last one. What was the question? Not repeated, but they must begin with a D and an E. Okay, so the first slot has to be a D. There's only one way of doing that. Second slot has to be an E. Only one way of doing that. Now I only have 2 slots left, and I've got 4 letters to select from. So I could have 4 different choices there and 3 different choices there. So there'd be 12 altogether. Another way of writing this would be there's 4 things, and from them I'm finding permutations of 2. So I could have 1 times 4 pick 2. Right there. Okay. Last question. This one is a little dandy one. It just makes you work with this formula that NPR is n factorial over n minus r factorial. So if I want to simplify that, this here, let's just plug these things in, the n and the 2, wherever I see an n and an r. Okay, so it'll be n factorial on the top, and then the bottom will be n minus 2 factorial. Okay, that takes care of this part. Now this part over here, I've got 2 times this stuff, so I have a 2 multiplied by, okay, this is my n part, so that's going to go up top there. So it'll be n minus 1 factorial all over, and then this 1 goes where the r goes. So on the bottom, I'd have n minus 1 factorial. Is that right? So plug that in for there, n minus 1 factorial all over n minus 1 factorial. Yeah. So these would actually cancel. So that would give me on the left side n factorial over n minus 2 factorial is equal to 2. Now I can simplify this a little bit, and it probably seems a little bit awkward. Get rid of this. But understanding what n means, or n factorial. If I have 5 factorial, it means 5 times 4 times 3 times 2 times 1. This number is always 1 less than that one. So n factorial, really I could write that as n times n minus 1 times n minus 2 times n minus 3, and I could keep going on forever. Or I can stop when I think maybe I can cancel something. So let's try using some of this over here. So this n factorial at the top here is going to be n times n minus 1 times n minus 2. Let me stop right there, because it'll be factorial, goes on forever. But rather than writing any more, I'm stopping there, because then I can cancel stuff. So I can cancel this and this. So then I have n times n minus 1 is equal to 2, or n squared minus n is equal to 2. If I bring 2 over to the other side, it becomes a minus 2. And then if I factor this, I get n plus 1, n minus 2 equals 0. So either n is equal to negative 1, which isn't allowed. You can't have an n that's a negative number. Or n is equal to 2. So my final answer would be 2. That's sort of a funny kind of question. You're playing with the idea of factorial and you're playing with that NPR formula. All right, hopefully that helps you with that homework.